98% of Saudi Arabia's land is nothing but desert. Yet right in the middle of this harsh, seemingly unlivable environment, the country has created its own rivers. Massive streams of water are drawn straight from the ocean, traveling across scorching deserts and climbing mountains more than 10,000 feet high, long enough to circle the earth 35 times. Thousands of pumping stations work nonstop, 24/7, delivering 5 billion gallons of water every single day to sustain 35 million people. And here's the surprising part. Saudi Arabia is one of only 18 countries in the world without a single natural river. No rivers, no lakes. The country's high plateau terrain blocks moisture from the sea, which means rain clouds can't reach inland. Add in the brutal climate, with temperatures often hitting 122 degrees Fahrenheit, and on a map it looks like a place where life simply shouldn't exist. When it comes to water, the numbers are shocking. Each person in Saudi Arabia has access to only 68 to 90 cubic meters of water per year. That's 5 times less than the United Nations' absolute scarcity threshold. For comparison, the average American has access to around 9,000 cubic meters per year. Humans can survive 3 weeks without food, but only 2 to 7 days without water. That's why, in Saudi Arabia, water has always been a matter of survival. To keep going, they turn to the desert itself, drilling deep to tap into ancient fossil aquifers, underground water reserves that took thousands of years to form. Since the 1980s, thousands of wells have pumped up trillions of gallons. By 1992, Saudi Arabia was consuming 7.5 trillion gallons of water a year, enough to fill more than 27,000 Empire State Buildings. But what began as a solution soon became unsustainable. Unlike rivers or lakes, fossil groundwater can't be naturally replenished. Once it's gone, it's gone. In just 25 years, water levels in the Al Asa aquifer fell by nearly 500 feet. By 2012, 80% of the country's 132 trillion gallons of groundwater reserves had already been drained. This crisis forced Saudi Arabia to take action. A survival plan was launched to cut water use dramatically, bringing consumption down to just 40 gallons per person per day. That's only 1/7 of what Americans use, about 300 gallons daily. Cities began installing smart meters and enforcing heavy fines for waste, from dripping faucets to watering lawns. Agriculture, which once consumed enormous amounts of water, was forced to adapt. Thirsty wheat fields were replaced with drip irrigation systems and moisture sensors, ensuring not a single drop went to waste. By 2015, agriculture alone was using 6.5 trillion gallons a year. But with these changes, the country began making water conservation a top priority. By 2020, Saudi Arabia had cut its nationwide water use down to 4 trillion gallons, a reduction of nearly 40%. Still, the average citizen consumes about 321 gallons per day, roughly the same as in France. These conservation measures bought the country time, but they couldn't keep up with the rising demands of a growing population and expanding agriculture. Just like America can't meet its energy needs by simply saving gas without creating new energy sources, Saudi Arabia realized it needed a massive, sustainable, and nearly limitless supply of water. The only real option was seawater, which makes up 97% of all water on Earth, but is salty and undrinkable. Saudi Arabia started experimenting with desalination in the 1970s, but it wasn't until the early 2000s that tens of billions of dollars in investments transformed it into a real solution. In 2015, the country's desalination capacity was just 1.66 billion gallons per day. By 2024, it had expanded to 41 desalination plants along the Red Sea and Persian Gulf, producing about 3 billion gallons of fresh water daily. That's 22% of the world's total desalination output. For comparison, the entire United States produces less than 1/10 of that, even though America's coastline is much longer. At the center of this system is the Ras Al Khair mega complex on the Persian Gulf. This single plant produces 264 million gallons of fresh water daily, enough for nearly 2 million American households and generates 2,400 megawatts of electricity, the same as two medium-sized nuclear reactors. Its pipelines and treatment systems stretch hundreds of miles, working nonstop to supply both clean drinking water and electricity to nearby cities and industrial zones. But building the largest desalination network in the world was only part of the challenge. The bigger question was how to make the process cleaner and more efficient, producing fresh water with less electricity and fewer emissions while demand keeps rising. The solution revolves around two core technologies. The first is multi-stage distillation, which includes multi-stage flash and multi-effect distillation. The principle is simple. Heat seawater, evaporate it, and then condense it back into pure water. But the scale is enormous. Picture hundreds of sealed steel chambers, each the length of a football field, where seawater is heated almost to boiling. As the pressure decreases from one chamber to the next, the water flashes into vapor at lower temperatures. That vapor is then condensed into fresh water. The advantage of this method is durability. It can last 20 to 25 years, and it can handle almost any type of seawater without scale buildup. Even the leftover steam is reused to spin turbines, helping to offset some of the huge energy costs. The second technology is reverse osmosis, a newer and rapidly advancing process inspired by the biology of human cells. Reverse osmosis works by forcing seawater through ultra-thin polymer membranes, only a few millionths of an inch thick. The pores are so tiny that even viruses can't get through, removing up to 99% of salts and minerals to produce water that is almost completely pure. What makes this process even more impressive is its energy efficiency. Thanks to advanced pressure recovery systems, modern reverse osmosis plants only use about 2.88 kilowatt hours for every 264 gallons of water produced. That's roughly the same amount of electricity needed to power 10 LED light bulbs for an hour. In comparison, older methods like multi-stage flash or multi-effect distillation once consumed nearly 9% of Saudi Arabia's total electricity supply. The difference is enormous, and it's the main reason the country has shifted almost its entire desalination network to reverse osmosis, while also tying the system to renewable energy sources to cut down on emissions. Today, desalination provides about 2/3 of all urban water in Saudi Arabia. In fact, every glass of water in Riyadh is connected to reverse osmosis filters, electricity, and solar power running around the clock. Alongside desalination, Saudi Arabia has also invested heavily in water storage. Over 500 dams have been built nationwide, with a combined capacity of about 2.2 billion cubic meters. The King Fahd Dam in Wadi Bisha, for example, holds over 325 million cubic meters, making it the largest in the country. These reservoirs do far more than supply drinking water. They help irrigate farms in the desert and even recharge shrinking aquifers. But there's another question. Most people don't think about what happens to the salt after seawater is filtered. For every liter of fresh water produced, up to 1.5 liters of concentrated brine remain. That's around 60% of the original seawater taken in. In the Red Sea, where many desalination plants are located, scientists have already documented coral die-offs and declining fish populations. Experts call this the hidden cost of desalination. If discharged directly, this waste brine raises both the salinity and temperature of coastal waters, threatening the ecosystem. To tackle this, Saudi Arabia is experimenting with new solutions, including deep-sea multi-port diffusers, offshore dispersion systems, and even brine mining to recover valuable resources like salt, magnesium, potassium, and rare metals. Instead of treating waste as a problem, the goal is to turn it into a resource. But solving desalination was only part of the challenge. The country still had to figure out how to move billions of gallons of fresh water across vast deserts, up mountains nearly 10,000 feet high, and into every city and village. The original pipeline rivers focused mainly on supplying Riyadh and the holy city of Mecca, while many other communities, some of them quite large, still lack reliable access to clean water. With the population continuing to grow rapidly, the pressure to expand this network is greater than ever. Riyadh had 5.2 million residents back in 2010. By 2024, that number had jumped to over 7.88 million, and projections show it could reach 9 million by 2035. To meet this growing demand, Saudi Arabia turned to enclosed pipelines instead of open canals, a decision that made perfect sense. Pipelines are faster to build, require less digging, prevent water loss from evaporation under the 122 degrees Fahrenheit desert sun, and protect against sand and contamination. The result is nothing short of massive. A man-made river system unlike anything else in the world. The main pipeline stretches 8,820 miles across deserts and climbs to altitudes of 9,186 feet, making it twice the length of the Nile River, including all branches. The total network reaches an astonishing 880,000 miles, long enough to circle the Earth dozens of times. It's so vast that Guinness World Records officially recognized it as the largest water pipeline network on the planet. Here's how it works. Water from desalination plants is first pre-treated and purified, usually through reverse osmosis, sometimes through distillation. After post-treatment, it's stored in huge tanks before being sent into the trunk pipelines. These massive pipes act like the main channels of a river, eventually splitting into thousands of smaller lines that deliver water to every city and village. Riyadh alone has storage tanks capable of holding nearly 1.3 billion gallons, the largest roof water capacity in the world. Altogether, the pipeline system can deliver up to 5 billion gallons of clean water per day, up the same as the entire state of Texas consumes on its hottest summer days. But building this network is no easy task. Each segment stretches hundreds of miles, and laying pipes across rocky mountain ranges is an extreme challenge. The energy requirements are enormous too. Desalination plus pumping already consume about 9% of the country's electricity, roughly equal to the power used by 20 million American homes on a hot summer day. Every single gallon pumped across the desert comes at the cost of burning more fuel. And then there's the desert climate itself. With temperatures soaring to 122 degrees Fahrenheit, mistakes can be catastrophic. If the kingdom had chosen open canals instead of pipes, billions of gallons would have evaporated before reaching people. That's why they committed to 880,000 miles of sealed pipelines, enough to wrap around Earth 35 times, ensuring every drop makes it to its destination. Pushing water uphill to altitudes of 9,186 feet is like forcing a river to flow backwards. Even short sections, just a few dozen miles long, demand thousands of workers, massive drilling machines, and high-pressure pumping stations running around the clock. Eventually, the limits of land-based infrastructure became clear. The sheer energy and cost of running this system showed that Saudi Arabia needed a new option. So in 2022, the SWCC Corporation, along with private partners, introduced a bold solution: floating desalination stations. These mobile plants are built on enormous barges anchored off the Red Sea coast. Each one is capable of producing fresh water at sea, bypassing some of the toughest challenges of land pipelines and offering the kingdom a flexible floating river for the future. These modular floating stations are game changers. Need more capacity? Just add another barge. Need water in a different region? Lift anchor and move it down the coast. Each one can produce up to 13.2 million gallons of fresh water every single day, enough for nearly 150,000 American households. To put that into perspective, that's more than the daily needs of many entire U.S. coastal cities. Unlike massive concrete desalination plants that take years to design and build, this system is fast and flexible. A ship docks, switches on, and within hours, millions of gallons of clean water are flowing into storage tanks and joining the national pipeline network. And when a region's emergency supply is covered, the vessel simply sails to the next place in need. This isn't just a short-term fix, it's a long-term strategy. The barges are being designed to integrate with renewable energy like solar power and offshore wind, helping Saudi Arabia cut emissions and get closer to its 2060 net zero target. Officials estimate this could reduce as much as 37 million tons of CO, and because the system is modular, the fleet can be expanded anytime, creating a true floating river along the kingdom's coastlines to supplement the giant land-based pipeline network. But the significance goes far beyond Saudi Arabia itself. Floating desalination brings clean water to remote areas without pipelines, creates thousands of high-tech jobs in operations and maintenance, and most importantly, it proves that the water crisis can be solved with engineering, not just conservation. And that raises a huge question. What if this became a global solution? Imagine floating fleets supplying water to Africa's Sahel, South America's Atacama Desert, or even drought-stricken California. If coastal nations cooperated, we could build a worldwide rescue network of floating desalination stations and artificial rivers bringing life-saving water to hundreds of millions. So what do you think? Could Saudi Arabia's water technology save thirsty regions across the planet? And will we one day see artificial Niles flowing through America, Africa, or maybe even right where you live? Let me know your thoughts in the comments, and don't forget to hit subscribe so you won't miss more surprising stories of how humans are defying nature to survive.